I want to say thank you to our sponsors, Deus, and for the food and drink, Bitnami, and I'm with StackPoint Cloud. So I am going to hand it over to you, Ryan.
Cool. I'll switch my mic on. Ready to go? Thank you. How are y'all doing? All right, cool. Thanks again to Bitnami, StackPoint Cloud, and Deus for sponsoring. Nice to have a space and pizza and all, and beer. Extra nice. Okay, let's see. I can clone. Same image on all. So since I work at RedHat, I have to wag my finger at all the Apple users and point out that I'm actually running Fedora on my Apple, not in a virtual machine or Parallels, running Fedora natively. And as a reward, I get about 50% of the normal battery life that usual Apple users enjoy. So let's see, let me get to some slides here. We've got a bit.ly link, K8's, no, it's SFK8's OpenShift extensions. Okay, so I'm going to be presenting off of, and hopefully I'm at the right room and location. So here's a link to these slides if you would like to follow along. I've also created a pretty decently sized Kubernetes environment with user IDs for everyone. So if you have a laptop or even a cell phone and you are interested in following along, I have just printed up a list of user IDs on these sticky notes here that I can hand out to the class. If you are not interested in following along, I'm going to do all the demos on my screen here, but I wanted to make it interactive, especially because we have a little bit extra time. So any hands of people who might want to give it a try? I'll pass some of these out. We'll be, okay, yeah, feel free to share them as well. There you go. You bet. Yeah. Or pass it back if yeah. There you go. Anyone else? Pass those down. And a couple more, pass them around. If anyone else would like to follow along, there's probably a couple extra stickies around, or wave your hand and let me know and I can get you a user ID. Looks like the Wi-Fi password is probably on the right side.
Bitnami is Harry, and then Bitnami is awesome. 3 exclamation points. No spaces, no capitals.
Remember it. Okay, cool. I'll get started here. So I'm, thanks all for attending. I'm Ryan from RedHat. I work on RedHat's OpenShift team. We've been doing, actually I have slides to cover what we've been doing. What I'll go through today is a quick introduction to OpenShift, how we relate to Kubernetes and whatnot. I'll cover how to build and deploy Docker images, or how we build and deploy Docker images with OpenShift. We'll do a little quick demo on how to iterate on container-based solutions. We'll talk about automating your container lifecycle management. That's mostly kind of looking at some features that I'm sure you are all well aware of in Kubernetes, so I'll speed through that chapter there. And lastly, I'll talk a little bit about how at OpenShift, how we do templating and composition of multi-service solutions for Kubernetes. Feel free to raise your hand if you have any questions. I'll try to make this interactive. Go ahead and shout it out. So OpenShift, we're currently on what we call V3 of OpenShift. We've been working on this OpenShift effort for more than 3 years, maybe 4.5 years or something. It started off initially was all written in Java, and then we rewrote it in Ruby, and then rewrote it again, and now we're kind of on our third major iteration. About a year and a half ago, we decided to, we're making that really tough call of, do we stick with what we got, or do we scrap it all and take a gamble on this new Docker thing, And at the time, Docker was pretty established, but it wasn't really clear what the overarching service architecture for managing Docker would be. And so we very early looked at Kubernetes. So our new stack that we're dealing with today, and pretty much for the last year and a half, we've been developing on, usually for our enterprise releases, we have RHEL 7 hosts. For our community releases, you could definitely run the same thing with CentOS or Fedora. We also have an effort called Project Atomic, which if you're familiar with CoreOS, this is a very kind of similar concept that Red Hat is also offering, where you can get basically a slimmed down version of all three of these distributions available as either RHEL Atomic or CentOS Atomic or Fedora Atomic. And so instead of having around 3,000 packages, you have about 300 in an Atomic distribution. And it comes with Docker and Kubernetes already installed. So it's kind of our slimmed down host for running, kind of like a container hypervisor, if you will. We also expect recent kernels. The reason for this is anytime you're doing Docker, you're emulating a Linux kernel environment, and you need a recent kernel in order to emulate all the previous kernels and take advantage of the Linux kernel backwards compatibility. We also rely really heavily on SE Linux and Systemd. SE Linux mostly as a way to protect our host machines, make sure people aren't breaking out of containers and compromising a host system. For our container runtime, we've selected Docker. We also are looking really closely at the OCI, ACI, AppC specs as well, and making sure that we have plenty of options as far as the container runtime goes. For lifecycle management, of course, Kubernetes is the clear choice with this audience, right? And of course, what you're going to have for your cluster state is etcd in that case. And for our application state, we use primarily Gluster and Ceph for our blocks disk storage. Any questions so far on this? No? Cool, I'll move it along.
Just be here, you said are you going to use AppC, or are you just looking at them?
We, our current supported container runtime is Docker, and we're definitely looking at AppC. I think one of the advantages is we get greater density of applications per machine with either the Rocket spec or AppC, and for some deployments, you might want to have an operational flag where you could say, hey, developers, ship me Docker. We'll translate it on the fly and then store it as open container spec in the back end. So you could take advantage of that increased density while still saying we support Docker, at least as an API. So we're definitely looking into it as far as is it supported yet. Just Docker is our primary target today. So we basically, at OpenShift, we've been using Kubernetes for quite a while, since the very, very early days. I think I've had a quote-unquote production public web available service that's been hosted on Kubernetes for almost 2 years now. These slides right here are actually, I developed at the DockerCon, the first DockerCon hackathon, which was almost 2 summers ago. So this summer I'll be at 2 years in production on Kubernetes with this site right here that you're accessing.
So I know this, normally I give this talk, I'll be at a conference, and I'll ask how many people have used Kubernetes before, and there'll be 0 hands that go up. So I know you guys have used it. I can trust that you already know a lot of the terminology. As a new user, sometimes you know, you may feel coming into all the new Kubernetes terms, I know I initially felt really lost. This is all tried and true. You guys are really aware of everything that's going on in this community. So I'll skip my normal kind of let's agree on terms, right? This is usually what I have to do for most audiences. It's like, okay, let's agree what a node is and what an image is, what a container is. Let's talk about replication controllers, and deployment config is where we start getting into some of the custom objects that OpenShift has added as an extension. So a lot of these, of course, you guys recognize, right? A pod is kind of your minimum unit of scale. Your replication controller or replica set is going to help manage those pods. And so once you get the hang of Kubernetes, you know, of course you want to learn how to create a pod manually and how to, you know, edit a pod spec. But should you be manually editing a pod spec and posting it to an API? Probably never. You probably want to use a replication controller to manage that and give you some lifecycle management around the pod. We've taken that same type of theory and taken it one step further. So what we have is something called a deployment config. We've been using this for a while. I know there's new alternatives from Helm now for deployments. But what we do basically with our deployment config object, our primitive API object here, is we'll create a new replication controller for each deployment. So you're one level of abstraction back. You have a set of automation where you can repeatedly update a group of pods using a deployment. And this will include some additional configuration and room for defining different deployment strategies. And I'll talk a little bit about that later. So I'm going to skip through. I know you guys already know all these terms, but feel free to raise a hand if there's anything that looks unfamiliar in this list of terms. I know I mentioned deployment config. Build config is another one that I'll walk you guys through, and you could see how we use this custom API object. And you could judge for your own purposes whether you think this type of object should eventually end up as a core feature in Kubernetes, or whether Kubernetes really deserves to be primarily an operational tool and not necessarily a developer tool. This abstraction that we've added really allows developers to iterate on new images, and this isn't currently really covered by the use cases for Kubernetes really well. So here's one thing I'll talk about. Of course, you guys know services. Routes is something that an abstraction that we also have to define. This works kind of like an Apache virtual host. You set up a host record. Anytime we have traffic coming in that matches that host record, we'll know to hand that route data off to the correct service, and then the service hands it on to the correct pod based on the networking rules and the labels that are defined there. Any questions on this slide? I stole this from one of my coworkers.
SDN is OpenContrail. SDN.
SDN. So there's a variety of software-defined networking solutions. There's also in the Open Container Initiative, there's a container networking interface that's also being kind of standardized. What we have, as far as the color coding on these pieces, the blue pieces were primarily developed by Google initially, and a lot of these orange pieces were either additions by RedHat or are separate objects that just exist in OpenShift's ecosystem.
So are you going to track the container networking spec that's coming out?
So what we have initially developed was a Open vSwitch implementation. I think a lot of our pluggable networking is switching to Flannel, I believe, and I'm not sure about future development there, but I can
Have you looked at the
introduce you
Project
to...
Calico stuff?
What's
Have
that?
you looked at the Project Calico stuff?
I have looked at it, but I'm not sure if our team is spending development hours on it currently. It looks really interesting. I know a lot of our time so far was around the Open vSwitch implementation, and I think we have some contributions on Flannel as well, but I'm not certain on that.
What's the main differences between Flannel and OPS switches?
You know, I'd have to refer you to, this talk isn't primarily a networking talk, unfortunately, so I'd be happy to introduce you to some of my coworkers who are working on the networking components, and we could take that as a follow-up. Feel free to ask me later. Thanks for the questions there, though. So hopefully I answered most of your questions, and what I've shown so far is pretty clear for you guys. Yeah, any other questions on this? Here's another slide that I stole from a coworker, and so I can't validate to every one of these claims, but there are a vast array of different abstractions for Kubernetes that have either recently landed or in 1.2. I think jobs and config maps and pet sets, and there's a huge variety of things that Red Hat has worked on, developed initially as independent extensions, and now we're moving them into Kubernetes as core features, or offering them, and Google and other folks are saying, yeah, this belongs, or no, it doesn't belong. And as Kubernetes grows, it sounds like what I hear from the core team is that they are more interested in establishing stability on the core APIs, locking down the changes and kind of freezing the core APIs, and requesting that any new feature development be done as third-party extensions that are developed independently, and then the community can review them independently, plug them into custom Kubernetes environments, evaluate them, and make a good decision on whether this belongs as core functionality or not. That makes sense? I have a slide on that a little later. So I'll link you not just to our OpenShift sources and OpenShift docs, but since we're dealing primarily with Kubernetes objects, the Kubernetes docs are another great resource for all of these object models that we're dealing with. You guys have your user IDs. To follow along, here's what you need to know in order to follow along. You can, if you're following along from home or watching this later, you definitely have the option of setting up a OpenShift environment using Vagrant. So here's the pieces you'll need. You'll need our command line tool. I already have that installed. You can get that on GitHub, on OpenShift origin/releases, and we have Go binaries for Linux, Windows, Apple, all the major OSs. So here's an example slide on how you might add one of these binaries to your path. I have inside my home directory a bin folder, and this basically drops it into your bin folder. So this is what I do to set up my binaries. And don't try this here on the Meetup Wi-Fi, but if you do want to spin up OpenShift environment and follow along when you get home or later, any other time, Vagrant init, the stevo/OpenShift-origin will get you the initial Vagrant file, and then you can Vagrant up, and that'll get you the entire kind of Kubernetes/OpenShift cluster all running as a single VM. So it's super easy, Vagrant up, and you'll have a full dev quality environment. One master, one node, both kind of
single instance.
So you have one master and one.
They're one VM, so the master and the node are the same thing. It's really meant for development. It's not two VMs, it's one VM that's a master and a node. So it's scaled down as small as you can get it, and really geared around the concept of, should developers be able to replicate a full stage locally on their laptop? And I think this gives you a really compelling opportunity to be able to pull down images from your staging environments and do a CI pass locally, possibly before you even commit your code.
So more than one master, different IP addresses.
It would all be one machine, but I'll show you how it looks.
Do you have
So
to install Kubernetes before that?
I think we'll get to it, and feel free to follow up if I don't cover it, but we'll see host names. And you could see how you could have multiple microservices do a integration test between themselves, if needed. So yeah, watch out on this Vagrant up. Be kind to the Wi-Fi. If you are doing the virtual machine, this is how you would log in. With that OC command line tool is OC login. And then this address here for the local virtual machine, if you did Vagrant up, right? You guys aren't doing Vagrant up. You guys are going to use this host address instead. So I'll do the login, and you guys could try it out. Like I said, you might need this OC command line tool. So here's the login really quickly. Let's see if I can. Open. Where am I trying to go? Okay, so I will log out and we'll log back in. I'm going to log in as the demo user, and the password for everybody is SFK8S. Unless you're on the virtual machine, and then you could actually use any password you want. It doesn't matter. So I gave you all a user ID. Don't log in as demo. Log in as the letters USER and then the number you have. So I have a user 15 here. I'm going to type in user 15. I'm going to type in SFK8S for my password, and fingers crossed. Let's see. Looks like I've logged in. Okay. Give it a try if you're following along. Raise your hand if you have any problems. Make sure you're using HTTPS. It only responds on HTTPS. It will refuse your request on port 80.
Thank goodness.
Yeah.
Sorry, what's the password again?
The password is SFK8S.
So 10.2.2.2 is the same.
10.2.2 is for the virtual machine, which you don't have on your laptop. If you're following along from home on the recording, this is 10.2.2 is what you want.
That's my local host ID.
That's if you're running Vagrant. And the instructions on running Vagrant are right here.
Okay.
So you should be able to, also if you want to log in from the command line, same thing. I'm going to do OC version to verify that I have the command line tool. Looks like I'm running release v1.1.6 from our releases page on GitHub. The Kubernetes API that I'm communicating with is 1.2.0- whatever this build number is. So this is potentially the quickest way to get you up and running with Kubernetes 1.2 in no time on your laptop, right? Or a very quick way to get it done just with Vagrant up.
What the password is?
Password, let's try that. I'll do OC login. I'm going to log in with this URL. I'm going to type in my username, which is USER, and then the two numbers on the little sticky note I gave you. And then the password is SFK8S. Got it?
let me know if you have any other questions or if you get stuck. I don't want to hold up people too much, so I'm going to proceed. Everyone good for now? Okay, cool. All right, let's start building some containers. Let's go for this. All right, so I'm going to do, from our overview, we got a quick chapter on builds, chapter on iterating. We'll talk about Kubernetes super quickly, and let's get to these builds. Okay, so build automation. We have, using the SFK8S.
Or it's on the link.
Okay, so build automation. One of our primitive objects that I brought up earlier was a build config. This is a standard, pretty standard Kubernetes API object. There will be a type field, a metadata manifest, and a spec and a status, just like every other object you see from the Kubernetes API. One of the items in the spec is a build strategy. So you can say, I would like to do a Docker build, which is a pretty standard, you can probably get that out of Jenkins. In fact, you could do any of these from Jenkins just as easily. This brings the build automation inside Kubernetes and makes it available via a Kubernetes abstraction. So I'm going to focus on our source build strategy using a tool called source to image. This is one way that we translate from, actually it's one way that we do our builds at RedHat. And there's, I guess, the reason why we do it this way is for security reasons. We have a very large site called OpenShift Online that allows people to sign up for free accounts. It's not running Docker yet, but at some point we're going to start allowing users to sign up and say, hey internet, everyone with a fake email address, come at me bro. Come bring your worst, and we get all kinds of people signing up trying to be Bitcoin miners and doing video proxies to YouTube and other countries or Netflix and all that. So we get all types of different scammers coming in, and one thing that we've learned is don't hand out root to random users that you don't trust, right? So the way we do our builds, we don't trust users with a standard Docker build, because in your Docker file you have things like a yum install or an apt-get install, and basically the whole Docker build process is executing in a root context. So you may need to take certain precautions. One thing that we do to eliminate the security attack surface here is we do all the operations that require root in advance. We have an operations team, and they do things like install packages and standardize our base images and hand out working images to developers, and developers can then, using a user space tool, add their repo code on top of the Docker image without needing any root permissions. And so everything that the users do is executed in user space, not going into a escalated privilege on Kubernetes. So that's one of the reasons is we absolutely have a scenario where we're like, we can't trust our users, and we want to build products for people who really want true multi-tenancy and high security on top of Kubernetes. So source to image is one of our tools now. If you're looking for tips on how to standardize your images and make sure that it'll run in high security environments, I run it through our source to image tool and see what gets outputted. And it's usually it's an image that you can run with a random user ID, hopefully, that's the goal. One of the reasons we do that is we want to make sure that if we spin up several containers and we give one a very clear security context and it's running with a certain user ID, that a different container running under the same UID, someone can't hack across the system and use that UID as to access someone else's security context. So we try to run every container with a random UID, and source to image is one way to kind of shoehorn all of this content into a format where we can choose random UIDs and up the security layer that way.
So source to image, this is available as a standalone project. You can use this in Jenkins if you want to help improve the security on your image building processes. We also have it available via Kubernetes. So that's what I'll show here. Let's go ahead and run a create. So if you would like to follow along, I would say check out my, my pillar base repo on GitHub. And if you're going to actually follow along the whole way with your laptop, I would say you actually want to make a fork of this, because we'll set up a GitHub webhook from your fork into this OpenShift environment, so you can trigger a build and automatically generate a new Docker image. So I'll show you how to do that. I already have a fork of this repo, luckily. Container statuses. Our web console actually hooks up to the Kubernetes API, monitors status changes, and reports those to the web dashboard. So we should be able to see that. I'll do this create example, and I'll create this repo here. Let me go to this dude. Go into my, go back to the same user that I have on the command line. Okay. So I'm going to do add to project. This is our web interface. This is part of what you get, what OpenShift adds beyond Kubernetes. There's the additional object types on the Kubernetes API, then there's also this web interface. So I'll do add to project here. I'll pick, these are the standard base images where you can layer your repo code on top of these standard base images. I just published a whole set of images for all the new Node.js versions up to version 6. I don't have it available in here, so we'll use this old crusty Node.js. But if you want to check out my Twitter feed, if you want to try Node.js 6, it's super easy to do. I'm going to make a new service. I'm going to call this service dub. And for the example repo URL, I'll put in this GitHub URL to my pillar base repo. This is a Node.js project. Put in your own repo source if you have forked this. Cool? All right, there's also advanced. Really quick, let's look at advanced. You could just hit continue and go right on through, but if you wanted to set a custom host name, you could set in a different host name here and then direct your traffic into the Kubernetes cluster. We'll check the host header, see if it matches, and we'll know to pass it on to the correct service based on this ingress rule. You can also define if you have a different target port inside the container. Usually we'll look at the expose statement inside your Docker file to sniff which port you're going to be running on. Here's our build configuration. You can see there's kind of a web interface, but this is backed by a API object, which we'll get a look at in a second. So I'll say I would like to configure a webhook trigger with GitHub so I can automate these Docker builds. There's also a way where I can automatically rebuild an image anytime the base image gets an update. So if the ops team goes and pushes an update to Node.js to patch a security vulnerability, let's say there's like shell shock or heartbleed or some major security issue, you don't necessarily want to trust your, I love JavaScript, I love my front-end devs. Do I want to trust them that all the security vulnerabilities have definitely been closed? Are they going to sign off on the security issues? Probably not. You probably want an operations team that can build standard-based images and a hook that will automatically build any application containers that have been based on this set of security standards maintained by the operations team. So this gives you kind of a dual trigger mechanism. Ops can automatically trigger a rebuild, and devs can automatically trigger a rebuild. Neither one needs to interrupt each other's workflows, and Kubernetes helps manage the whole thing. We're also going to, here's our deployment rules. This is basically my continuous delivery checkbox. Auto deploy anytime a new image is available. I'm going to leave this selected because I'm assuming this is my development workflow. If this was production or some other stage, I might not have this selected as my default config. But I'm probably going to have a different template
for each stage of my pipeline. And we'll talk about packaging together all these objects as a template next. So auto deploy, and I could set, if I wanted a high availability configuration, I could say, let's give us a minimum of 3 right when this starts up. let's init it with 2 and see how this goes. So it looks like the application is scheduled for creation. We can see there's a new service defined. I'm actually going to click on this and we'll see that there's no pods available for the load balancer or the service to hand off the traffic to. So right now we're getting a 503 error. Let's go and look at the build as it happens in the dashboard. I'll hit follow here and we'll stream these logs in as the build happens. Looks like it's already done building and we're pushing the image. If I try to run my builds on Docker Hub, I know they're not like paying a lot of money for their hardware and trying to subsidize the whole community, but my builds will often take, it's like ordering a pizza. It's like 30 minutes or less if you're lucky. Like hopefully your build finishes in half an hour abouts. Has been my experience on Docker Hub, and it's a free ride, so I don't expect too much, but I generally get, you know, a minute or so build times in here. Pretty good, almost good for me to like fully say I can iterate on this as a developer, right? Not quite there yet, but pretty good. So this should be pushing our image into our Docker registry. Anyone else trying this as well? Everyone else fell off?
It will go back from the beginning, how you created.
Okay, how I created. Here's our scale up happening. It looks like the deploy finished and we're up to two pods, right? Pretty easy. All on a web-based workflow. So I'll walk through that one more time. I'll do add to project. I'll pick the Node.js base image. I'll call this, what did I call it? I called it dub, so my examples are going to be wrong. But you can call it pillar base, and that might go better with the examples. And here is the GitHub URL. It is included in your slides. So you could just do those and hit create.
I can put in my local host, right? Instead of our.
If you want to load a private repo, that's a little bit trickier. I have an example ready to go though. You can definitely use this and it'll work. If you don't like this repo, I got a couple other Node.js repos. Anything that listens on port 8080 hopefully will work as long as it responds to npm start for its init. And if you don't like Node.js, you can try PHP or Ruby or even Perl or Python, or we have a lot of different languages. Go ahead, that's why I set up the workshop. Go ahead and have fun. Just if you go off course from what I have in the slides, some of my subsequent slides may apply slightly less.
Do we support JSON format?
JSON?
Yeah.
For Node.js? Oh, this is just a Git repo. So whatever's in your Git repo, if it runs, we can follow up on that. Yeah. So you should end up with something like this. You'll probably be on one container, and you could hit the up arrow in order to adjust your scale and resize your replica set. So pretty good. Whoops, lost the video feed. Pretty good API, web console support for doing basic administration for resizing a replica set. Let's get back to the slides here and see. We did our create. Let's go and take a look at this. We saw what it looks like from the web interface. Let's see the same thing from the command line. So I'll do OC get pods, and I can see this is really similar to what you might expect from running kubectl or kubectl get pods. Let's see what the difference is here. Looks like it's the exact same format. The only thing is we've filtered out our build container when giving the results to kubectl. Because this was dealing with a non-standard API object, we decided to drop it from the output, it looks like. Also, this is a completed container that we're really just keeping around so you can check the build logs. And this would be automatically garbage collected at some point. So it's hidden from the Kubernetes command line output. But otherwise, exact same format. You can use the underlying kubectl tool for 90% of this stuff. The OC command line tool just has visibility to the additional API objects that are not covered by the core feature set that you get from kubectl. Any questions on that? Does that make sense? Kind of? Okay. I'll try to keep it moving here. All right, get pods, and we did core APIs, CLI output, and everything else compatible with standard Kubernetes. So if you just need a get up and started with Kubernetes, you can totally use this, just the back end, to set up your own Kubernetes very easily. So we've done a quick build and deploy. Now I'm going to show you iterating on containers. So we'll develop on, I'm going to make a change. Ooh, I've got a local copy of this repo. Let's actually load it and prove that it's working. Okay, here we can prove that it's actually working, right? I visited this URL before and we got a 503 error. Now we have a title and some basic CSS that we're loading. Basic application up and running, right? So let's go make a minor change and see how that gets reflected in the service here. So here's my local checkout of this pillar base repo. I'm going to make a quick change to the index file, and I'm going to say welcome to your pillar.js application on OpenShift, and I'll add an exclamation point at the end of the title. All right, pretty simple change. Let's try this out. I'll write that file, and I'll run this command here. This is going to, let me raise this up a little bit for folks who are not right in front of the screen. So here, this is a OC rsync command. This is going to rsync changes from my local file system into a running container that we've already deployed. So it looks like I'll need to get one of our pod names here. Let's do, just so we can make sure we land on the right pod, I'm going to make this easier for us. I'm going to scale us down to 1. I'll check our list of pods. It looks like I've got one here that I should be able to copy data into. I'm going to grab this pod. And let's do that rsync, and I'll refresh, and we'll see if we get an exclamation point. Not bad. Okay, so pretty good. This is, I didn't even have to wait for a rebuild. Now you can see I could actually iterate on this code. I know I'm just changing HTML here, but we're actually working on, it's not available in this particular release of the OC command line tool, but we're adding a -- watch flag to this to continually watch the local file system and rsync changes into your running container, so you can preview the changes you're about to make before you commit, right? So now imagine I have not just this one service here with a host record, but I've deployed, also pulled down maybe 2 or 3 images from my staging server, given them host records. Now I can do an integration test against my other service dependencies and check the results to see if they integrate and if they'll talk to each other correctly before I even make a commit. This is pretty good. I think I'm actually getting to like a developer experience with Kubernetes that gives me a lot of value, and I can iterate just as quickly as without containers. Yep.
But if you were running 3 pods, would you actually have to do it one by one?
That is a great question. I only have this one example here, and it looks like what our watch command is looking for right now is a container ID. So yeah, we may need a wildcard, or maybe to match on the service label, or like we might want to match on some Kubernetes label selector if we want to apply this to multiple pods. That's definitely
that last one.
Yeah. Yeah. So yeah, we're adding a watch flag to this that'll make it even nicer over time.
So,
yeah.
how many you can scale up? What's the maximum you can do with?
Please, if you would, don't scale up beyond maybe 10 or so individually. I created an environment like 2 hours ago for you guys to play around with. I'm going to burn it to the ground tomorrow morning, but feel free to monkey around with it. But if you attempt to scale up to 1,000 pods, you'll definitely kill my demo. So please be kind. So attempt it on your VM instead, if you will.
Can I pass the environment parameters in those, yeah?
You can. There's a variety of ways to do that. First, I'm going to show, that's coming up next. One thing I'm going to show here is now that we have our container up and running, I'm going to go in here and interact with the container live. Let me show you how I found this. I could either go to Browse. Browse has a list of a lot of our Kubernetes API objects, so we can go browse our pods. Grab here's our build that finished, here's our running container. I'll click on the running container, I can check the logs here, and these will stream live into the container as the logs are updated. I can also get an interactive terminal live on the web here, and let's check the process list. Looks like PID1 is npm, so we're clearly inside a container. In this environment here, and if I do ID-U, you can see I have a random user ID inside this container. So if I had multiple containers, hopefully I couldn't use the security context from one container to hack into another container, because they're all running as separate users and separate SE Linux contexts. So they're all running in a SE Linux jail, essentially, mapped per user ID. And we could also get a similar interaction right from the command line here. Here was our pod ID. I'm going to do OC exec to this pod ID.
How can I go to the CLI command from the web?
Yeah, I'll get to that next. I'll review that. You can do, here's the same thing. I'm interacting from the command line, right? OC exec provides the kind of Docker exec style functionality. From the web, one more time how I got to this terminal.
No, to see the other CLI command, not this one.
You want to see this?
Yeah, how I do it now.
How you do the OC
How
exec?
can I log in to see it?
Yeah, you want to do, here I'll show you on the slide, OC exec. And then it's just like the Docker exec format. So IT for an interactive terminal with a TTY, and you'll have the pod name. You'll need to get the pod name using kubectl get pods if you have the kubectl command, or OC get pods, and that'll tell you which pod name that you need to use. Where can you see what?
ETI terminal. How can I log?
You would type in this command on your laptop? I don't know, you don't have a terminal app?
Oh, I have to use another. Got it.
Yeah, you have to open up your terminal app, and then you need the OC command line tool that was at the beginning of the slides. So I showed one way to iterate using the OC rsync. I'm going to show one more way really quickly, unless nobody cares about this. Does anyone care about seeing a build from GitHub? Any hands? I could totally skip it if you guys don't care. What I was going to show next is log into GitHub, set up a webhook, make a change on GitHub, and have that webhook call me back and rebuild the container. Thumbs up? Anybody? Nah? Not? All right. Okay. Well, this is one developer use case that we're trying to layer on top of Kubernetes. Just FYI, y'all. And if you don't need developer use cases on top of Kubernetes, you can at least see how we are focusing our extension development, and you could evaluate for your own purposes whether these belong in core at some point or whether they don't. I think it's a larger conversation that we'll have over a year or more. So,
So the only question I have on that workflow is the webhook guaranteed delivery? I mean, can you drop the event?
you know, I don't know GitHub's policy on that. I think it's just a single fire event whenever the commit lands on GitHub.
So
I
if you're
haven't seen a
answering service,
retry.
if you're answering service on OpenShift is not actually reachable at that time. You're probably don't.
Yeah, if your Kubernetes cluster is down, it won't get the callback from the build system. On the other hand, you could always do something like this. From the web interface, you can kick off a build, and from the CLI, you can automate the start of a build. And this is really what you would probably do in production environments, is maybe not rely on that webhook. That's probably just for your CI stage or your...
Yeah, you start to build manually.
Yeah, exactly, on the later stages.
I figured that was it.
Or you'd be using images that were already built in previous stages, and you're saying, hey, these have already passed every check, we're not rebuilding it, we're doing the tested images, we're using this signed checksum, and we know exactly what we're shipping at that point. You asked about environment variables. Here's one way to edit environment variables from the command line. You will need a terminal of some sort for this. But I'll show an example here. I called my application dub, so it's going to say, I don't know what pillar base is, but we'll edit the deployment config for the dub service, and I'm going to set hello to SFK8. That will set a new environment variable in our deployment config. Since there's a change of our ideal status of what we want to ship, this will actually trigger a new deployment. And I missed it already. It's already done. It looks like we're on deployment number 2. So I should be able to show that the changes have been applied. Let me echo hello. And here's our SFK8's environment result has been injected into the container. There was a redeploy the image in order to make that happen. But super easy to set an environment variable as part of your replica spec. Let's take a look at this. So since we made a change to this, instead of doing this ocenv command, I'm going to do ocget on the DC resource with this ID. And we'll output it as JSON. And let's take a look at what this looks like. So you can see there's a deployment config object type. It's version data. This is probably competing with the Helm and deployment manager spec. And now that they've officially been more or less blessed by the Kubernetes community, I'm anxious to see whether we will be adopting their spec or how we'll proceed as we go forward on this. So definitely good stuff to look at, and thanks again to Deus for sponsoring. But here is our deployment config object, and you should be able to see, if I scroll down, that there is a hello environment key that's been defined in the spec that was shipped. Any questions about that? It's a big file with a lot of different details. The best way to learn more about it is look at the spec structure, and we've got all the details for different deployment strategies, different ways to roll out those changes across your cluster. Logs are also available. We do centralized log aggregation and metrics that go into a elk stack and popular type of setup. So that's something that you get out of the box, and it's included with our local development VM. So when you spin up that all-in-one VM, it's got a master, a node, and Hocular all ready to go and running. So we're working on centralized log trains to make sure when you do have a high availability multiple pod configuration that you can update multiple pods and read from all the logs across the multiple pods, and then do queries on that data as well. So I talked very briefly about deployment strategies. Here's a link if you want to learn more, and we have some demos with canary deployments, blue-green deployments, a variety of different deployment methods for rolling out those updates. So maintaining, how am I on time? I've talked my way into the second session of the guy who's canceled, so I'm still clear, I think. All right. So maintaining this one, I'll go through this pretty quick because you guys are all pros and you know all this stuff already about Kubernetes. What I usually cover in this segment is doing some scaling. So we provide this, you've seen the OC command. I can do OC edit on this deployment config. Since I'm a JavaScript guy, I prefer JSON versus YAML, so I'm going to do, sorry you don't get a choice, I'm doing JSON, here we go. Here's our deployment config. I can go in here manually and make changes to the number of replicas, and I could set this to 3. Let's verify where we're at on the web first. Looks like we are at 1 pod. I'm going to set our replica set to 3, and I'll write and quit this file. Guess what will happen here? Boom, deployment, created. Sorry about these errors from VI, I don't have it configured quite right, but this indicates we've posted that updated content back to the Kubernetes API. So if I did, let's say I jump in here again, and I make a couple changes, but then back it out, and I don't actually write any changes, here it says edit canceled, no changes made. So it'll diff the object, make sure you've actually modified it, send the modified copy back to the API with an easy command. Although this is still not easy enough, you shouldn't be manually editing your JSON. So we do you one better for your development purposes or administrative purposes. Here is the OC scale command. And so I can set this replica back down to 2 pretty easily, and we should see the web interface automatically respond to the changes in the core etcd database and be reflected through the Kubernetes watch endpoints.
You have to use CLI for it?
You do not, and here's from the web. I could scale up really easily from the web using these little paddle flippers here. There's also, if I wanted to edit the whole thing, I can go here into deployments. I can look at this particular API object, this ID of this object type, and I can click on edit, and here's the actual raw YAML in this case. I can go in, I could say our replicas were 5, let's change it back down to 1. I'm not sure if this works actually. Let's see. Looks like we're back down to 1, right? So you could do web-based editing. This is why if you don't have a terminal, you could almost follow along with your cell phone for some of these examples with this web interface here. Scaling, auto recovery, you guys all know this part. We could do get pods and then delete an individual pod and watch Kubernetes replication automatically restore it. So I'll skip, you guys, this is boring, right? Skip over this one. Okay. You want to see replication? Or auto healing? No? Any hands for auto healing? Yeah? Super quick, yeah, all right, let's do it. So I'll scale up here, let's give it 5. Set our new replica size. I'll do OC get pods or KubeControl get pods, either way. I'll intentionally cause some damage to our cluster here. I'll delete this guy, and this guy. And we're currently at 5. Let's see what happens when I hit enter. That should schedule the deletes. Looks like we lost some capacity, but Kubernetes goes right to work at bringing us back up to our full allocation of whatever we've requested from the API. It's Kubernetes' job to continually do, let's see if I do get DC dub and grep for replicas. Replica. Maybe I want the replication controller. I'm missing something here. I'm not exactly sure what, oh, -o JSON, here we go. So this has two fields. There's a spec and then a status that are coming back, and it looks like they're both at 5. So did this, maybe my WebSocket connection dropped. I'm going to refresh and hope I'm back at 5. It says one's still pending. Not sure what the holdup is, but luckily we have nice aggregated logs to go investigate all of this stuff in case it fails. Usually this type of scenario could be that it's out of resources and can't provision and is blocked on fulfilling the request or something. I can go and dig into the data and try to debug it, but I'll loop back around to that. In the interest of time, we'll save that for a later exercise unless people really want to get into debugging. So last chapter I have here is on composing services. This again is looking at our templates, and we'll kind of cover a look back at what I've done so far on the web and apply it to the underlying object types. So here's an example. If you wanted to deploy just a basic image right from Docker Hub, I could deploy the Kubernetes guestbook application using our OC new app command. I'll give it the URL or the reference to the Docker Hub entry for the Kubernetes guestbook, and I'll say, instead of going and creating this thing right now, why don't you spit out all of the data that would be generated and passed to the API? So I'm going to do -o JSON, I'll view this, and let's see, still working on contacting Docker Hub, finding out the spec for the image, generating the data. Here we go. This is what was generated from that one command. There is a Kubernetes object list. One of the objects is something called an image stream. This is basically a object in Kubernetes that's basically an event trigger that throws events anytime a image changes in our integrated Docker registry that we package. So this will let you know if the operations team ships an update to a base image. This will fire an event and say, hey, any application built on this needs to get rebuilt itself. Other objects, there's a spec and status, just like anything else you'd expect from Kubernetes. Deployment config was another object that we covered earlier. This would be automatically generated by that OC new app command, and this in turn will automatically generate your replication controllers or replica sets. There's also a service, and that looks like it for that particular example. If you want to see building from a local directory, you talked about building from something local on your laptop. If that something local includes a Docker file, you could do OC new app with your current directory or a path to a Docker file anywhere on your laptop, and then -o of YAML or whatever. It'll spit out all the API structure, object structure that would be passed to the API. If you want to just do new app right away, leave off the -o and it'll just invoke it. It'll create it on the API. But if you want to see the object structure, add the -o. This is all these examples is trying to show you the native underlying object structure. Last example here I have is what we did was OC, we did a new application with a Node.js base image and a GitHub repo. This is exactly what I ran from the web console, and here is the resulting API data generated on the command line that the web console ended up passing to the Kubernetes API. Got it? If you want to actually pass this data to the API, pipe any of this data to OC create -f or kubectl create -f, and it should get passed to the Kubernetes API. Does that make sense with what you guys understand of Kubernetes? Yeah? Cool. Feel free to follow up with questions if you have any. So OpenShift templates are basically just a low-level list of Kubernetes objects with support for basic parameter injection. If you want to see what one of our templates look like, I have an example. Oh, we also have a command for processing these templates. So if you want to get inject parameterized values into a template and get just the raw object list, this is a step for doing that, for resolving a more complicated template into a base set of native objects. We actually have a way of installing these templates and into Kubernetes as a abstraction, and then recycling them and making them available on the web. So I'm actually going to take our multi-service app example, and instead of creating it right away, I could create this multi-service application in one command, and it'll create all the individual services since they're all defined in this template. But what I'm going to do instead is I'll do OC create, and I'll install this template into our templates abstraction. What that'll allow me to do is go back here on the web, and now I can do add to project, and what should be available here is the new template that I've installed. Now I have a one-click launcher for anyone in my team that needs to consume some set of resources or a solution that's been packaged up, has a one-click launcher to go in and say, yes, I would like your Node.js image, your MongoDB image, some web service code to be layered onto this image, and we'll run a build based on this GitHub code. We'll make a new service with this service name. We'll generate a new database user, automatically pass that credentials into the front end web service and into the back end so they can agree on which credentials to use. And you can set policies on how these credentials should be generated if these fields are left blank. So you can kind of guarantee pseudo-random users and passwords for each of your environments, each new deployment. So I'll hit create. We'll go in. I don't think I've downloaded the Mongo image yet, so pretty quick. Okay, there's deploying Mongo, and for the front end, it's scheduled to build and is doing that source to image build. We didn't really get to see the log scroll last time, so should be log scrolling as the, I guess our output isn't, there it is, okay, into the logs. So it's already pushing the image into the integrated Docker registry. As soon as it lands, that image stream object will fire an event notification, which will trigger our deployment config. Since I set it to auto-deploy anytime a new image lands, it'll auto-deploy, and we'll end up with a full MongoDB backend and mapping front end. So here's our 503. Now that we've booted, let's see. Wait for the server to boot. I think the pod has booted, but the web server hasn't. Okay, here we go. All right, so this has pins on a map. So every time I pan and zoom, it's doing a spatial query on our MongoDB database and rendering a new set of pins for the front end of our map. So pretty good. We've spun up two services, passed credentials into our front end and our back end, got them to agree on a unique password, and deployed a whole kind of multi-image solution all in one click. If you want to see the source code for what that template looks like, here is the template. You can see we're injecting things like the database service name, really just simple parameter injection. I think Helm and Deployment Manager offers much more sophisticated templating if you have a use case for that. Here's how we do our variable interpolation. Let's see, where's my example? Here's our parameters section. There is some name and values with some default. You could also set certain fields as required. And here our database user, you can see we are going to generate the username from an expression. We'll start it with the letters USER, and then we'll have 3 random characters from this range, and that'll be our username. So every time we do a new invocation of this template, it's a unique username, a unique password, unique set of credentials that the front end and the back end can both agree on. Or people can inject their own parameters if that's what they need to do. This just gives you a nice way to spin up a great set of defaults. So we mentioned Helm. You could also get straight up Docker Compose templates and try out this Compose project. Compose with a K is meant to, I haven't actually tried it, but I heard it's good for converting from Docker Compose to a Kubernetes object list format. So there's a variety of options. Give me feedback if you got other things I should try. I'd love to hear what you guys are working on. And if you want to extend Kubernetes beyond the basic limits of what you find in the core libraries, here's a link to last week's K8's weekly community meeting. There's a recording where Brendan Burns presents kind of an introduction to third-party resources that are being included in Kubernetes 1.3. And so check out this video if you want to learn ways that you can extend Kubernetes, add custom object types to fit your particular use cases, and add in additional automation. Our particular focus has been around developer automation, iterating on images, and then adding in features for providing that web interface. But you can extend Kubernetes in whatever way makes sense for you, and then we can all argue it out on which features belong in the core and which don't. So if you'd like to try, I'll wrap it up here. If you'd like to try OpenShift, we've got releases on GitHub. We've got OpenShift.org/VM has our Vagrant image. We've got an OpenShift Ansible environment. I used Ansible to spin up the classroom from tonight. Took me like less than an hour and one command, so pretty easy. Hit me up if you have questions about that. We have support from RedHat. If you want to do, if you want support for Kubernetes, RedHat would be happy to take your money. Also, we would be happy to serve as your ops team if you want a dedicated cluster. We have a OpenShift dedicated solution that we can operate your Kubernetes cluster if you like. We also have plans for a new OpenShift on release and a developer preview coming for that soon. Thanks for sticking around. I have some free stuff for you guys if you like. I've got some OpenShift shirts if you're interested, and a big stack of stickers. Also, free ebooks if you're interested in any of these ebooks. Click on any or all three of these links. We've got an ebook on Kubernetes, scheduling the future at cloud scale, Docker security, microservices. Just click on any of these, and if you need the links, they're all here in the slides. So feel free to give it a click. And thank you so much for following along. Any questions? Are you guys good?
How quickly do you guys integrate the drops from Kubernetes and all the other components? Because they're on a different release cadence than you probably like to be on.
Yeah. We tried to come out with our OpenShift 1.2 almost at the same time of Kubernetes 1.2, and then they got delayed a bit, and then we are now trying to be maybe trail a week or two behind a major Kubernetes release. But usually we're dealing with pretty upstream code. I think we're already on 1.2.1, and some of the stuff we're working on is upstream features that's hidden underneath some feature flag or not even fully supported in the core APIs yet.
There's what you're working on and what you release. I'm more interested in what you're actually giving us.
What we are working, everything we have is all on GitHub, and I think it's, a lot of it is exactly what we released. Yeah, our enterprise solution is basically our exact same code, just with tech support or without tech support.
So effectively you're going to try to make a drop of OpenShift every time Kubernetes or Docker comes out with a material change.
Basically, yeah, and it's been a challenge. It's been a rough ride. But we got some cowboys, so we've been handling it. But yeah, it's been a challenge. But you can usually get almost the latest upstream Kubernetes in just about all of our releases, and that virtual machine that we have really closely tracks the upstream Kubernetes code.
Excellent.
Anyone else?
When you do an Upstream updates an image and it triggers a reload all containers, what happens to all the pods?
So that depends on your, that's a great question, thank you. It depends on your deployment config. In our case, you would have a deployment config probably per each stage of your pipeline, and it would depend on what you have in there. You might do, I think the original deployment was tear down and rebuild, just destroy the whole thing. What we have nowadays, let's see. Let's see, I got 5. I don't know, this isn't fully at 5, so let's see what happens. I'm gonna kick off a new deployment. Deployments. I'll go to dub was the one that I have at 5, and I'll hit the deploy button, and then hop back to the overview, and we could watch what happens. So here is our deployment 2 and 3. We're going to start scaling this down at the same rate that we scale this up. And we try to keep it, if you've requested 5 in your replica set, we try to keep you at basically at even 5 and do a rolling update. So you're tearing down the old RC as you're spinning up the new RC. So this is up to full 5, and this is still stuck with whatever that one container that was sticky. I don't know what the problem was with that particular container, but it's the cloud, so we can kill it, luckily. Yeah, thanks, good question. And you can mutate those deployment strategies and define a couple ways of rolling out your code. Any other questions? Yeah?
So your example, you were showing a single MongoDB database.
Yes.
What if you wanted to do like a MongoDB reference set?
That is awesome example. Like, we have examples. I don't have it in this deck of slides, but I can definitely follow up and give you a link to a Mongo with replication. And we also have
sharding also, right? Mongo sharding also, you can do like
I'm not sure if it has sharding. I know we have an example with replication for Mongo, and I know we have an example for Postgres that's a high available Postgres with master-slave replication for, or leader-follower, whatnot, whatever you have for that, for Postgres. So I'd be happy to give you examples for those. Let me see what I got. The best place I usually look to for that is OpenShift, Origin. Here's pretty much all of our source code. Most of it is in Origin, other than that source to image, which is a separate project, and a couple other separate projects. But we have an examples folder, and I think in here in the DB templates, there might be, Mongo ephemeral and persistent, but I don't see a replication for these. I know it exists, and I'd be happy to follow up with you. Cool, thanks a lot for sticking around, and feel free to grab a shirt or stickers or anything else. Thanks again.
Thank you.